As per usual years, I'll go through this NHT Specialist Math Exam 2, and it was released yesterday on VCAA website. Let's have a look at the multi-choice questions. Consider the statement if n squared plus 5 is odd, then n is even. The contrapositive of this statement. Okay, so the negation of this one is n is odd. That is your if. Then n squared plus 5 is even for n belongs to z. Okay, so we choose option D. Next question. Number of straight line asymptotes of the graph of the function with rule f of x equals to a quartic divided by a quadratic. So what I'm going to do is I will just go for expand fraction 2x to the power 4 minus 6x cubed minus x plus 3 divided by x squared plus 2x minus 15 x. So you can actually see this is rational function, but the only vertical asymptote is x equals to minus 5. The other part is a quadratic function, 2x squared minus 10x plus 50. This is an oblique asymptote, but it's not a straight line. So there's only one straight line asymptote, option B. How many integers values of a can this fraction be expressed in the partial fraction of b over x plus small b, c over x plus small c? B and c are integers, and capital B, C are real numbers. Well, the way I think about this one is it could be written as minus 7 plus 3. So you might get a factorized form like that, or x plus 7, x minus 3. Because B and C must be integers. These are the only combinations you could think of. And minus 21 can also be written as minus 21 x plus 1. Or for minus 21, you might get, let's say, plus 21 minus 1. So therefore, you get 4 possible cross products. And there are 4 combinations. That results in, let's say, 4 possible values of A. Question 4. Consider the complex numbers z and w. W is minus 1 plus root 3i. ZW equals to 2 root 2, and the argument ZW equals to minus 7 pi over 12. So actually, I would call this one, let's say, a U. U equals to 2 root 2 cis minus 7 pi over 12. And then, if I want to get, let's say, Z, I need to use U divided by W. And the question wants argument Z to the power 3. So what I'm going to do is, with my CAS calculator, I'll first calculate U divided by W. That is 2 square root of 2 exponential I times minus 7 pi over 12 divided by minus 1 plus square root 3i. So you actually get, let's say, the expression for complex number Z. And then I just go for angle that number to the power 3, which is like a pi over 4, okay? Of course, I can do this question by hand, but because this is an exam 2 multi-choice question, I just do it by CAS. You might want to, let's say, get a W in, let's say, polar form, like a 2 cis plus 2 pi over 3. This is in the second quadrant. If you draw a diagram, this is minus 1, this is root 3, etc. Okay? So that is a possible way you could tackle this question. All right, let me just recover my connection. Yep. Let's have a look at question 5. The equation of the ray on the Argand plane. Oh, this time they say Argand plane rather than the Argand diagram. Anyway, the starting point of this ray is minus 2, 3. So I'm expecting an argument z minus 2 plus 3i. And then it equals to an angle of inclination relative to the horizontal. So this is a minus pi over 4. And z plus 2 minus 3i equals to minus pi over 4. So I would think about option B. Option B is the correct answer. Let's move on. Euler method is applied to the y dx equals to e to the power x with initial values 0 and y naught. For step size h, the value of y3 will be e to the power h plus half to the power 2 times h when y naught equals to a certain number. So what I'm going to do is, this time I'm going to do calculator approach, I would say. So first of all, I will define f of x equal to exponential function power x. And this is my derivative. Now, my initial value, x value is 0. So I say x1 is x naught, which is naught plus h. And then I say y1 is assigned to, you can use control template button. Y naught is an unknown, so just leave it as 1 naught plus h times f of x naught. X naught is actually 0. So this is my y1. Then I will say x2 is assigned to x1 plus h, and y2 is assigned to y1 plus h times f of x1. And then x3 is assigned to x2 plus an extra step size, and y3 is assigned to y2 plus h times f of x2. So you get an expression like that. Then what I'm going to do is I'll say solve y3 equals to exponential power h plus a half square times h, comma y naught. And I'll be able to get a y naught equals to minus 3h over 4. So which option is that? Option A is that. Okay, water is poured in at a rate of 5 cubic centimeters per second into an inverted right circular cone. So this is my dV dt in. The cone has a height 20 centimeters and a radius 10 centimeters. Now, at any height, let's say this is a particular height. You have an h here. This is h. This is a radius. The radius and the height h will always keep a ratio, let's say 10 over 20. So I'm going to get r over h equals to 10 over 20, which is 1 on 2. So r equals to half h. Therefore, the volume is pi on 3 r squared times h. And that's pi on 3 times h squared divided by 4 times h. So you get a pi h to the power 3 divided by 12. Then you'll get a dV dh equals to 3 pi h squared divided by 12, which is pi h squared divided by 4. Now, the question also says, water flows through a hole at the vertex of the cone at a rate of k root h. So this is my dV dt out. Therefore, my total dV dt, combined dV dt is 5 take away k root h, okay, rate in minus rate out. And my dh dV is going to be 4 over pi h squared. You can just get the rate at which the depth of water is increasing, like a dh dt equals to dh dV times dV dt, something along this line. Then you just get this split multiplied to that. Option C looks like the correct answer. Okay, using the substitution x equals to tangent theta. Minus 1 to 1, integral 1 over 1 plus x squared, whole thing squared is equivalent to something. So if I have x squared plus 1, that is tangent squared theta plus 1, which is secant squared theta. Now if I take the derivative dx d theta, that is a secant squared theta. So I can just multiply the d theta over there and replace dx. Also, if x equals to minus 1, that equals to tangent theta. I'll actually get, let's say, theta equals to minus pi on 4. If x is 1, my tangent theta equals to 1, and the theta should be pi on 4. So the integral will be theta equals to minus pi on 4 to theta equals to pi on 4, 1 over secant squared theta, whole thing squared times secant squared theta, d theta. Okay, so I'm replacing dx with this differential. And you can cancel out secant squared. So you actually get minus pi on 4 to pi on 4. And 1 over secant squared, that is a cosine squared theta, d theta. Notice that the graph of cosine theta looks like that. You can actually use 1 plus cosine 2 theta over 2 to replace cosine squared theta. So you actually get a graph like that. For example, this is from 0 to pi. And the other bit, if I go back to 0 to minus pi, this graph is symmetrical. So instead of using, let's say, minus pi on 4 to pi on 4, I can just calculate this bit and double it up. So you can actually get two lots of 0 to pi over 4 cosine squared theta d theta. So I believe the answer should be B, if I'm not mistaken. Alternatively, you might want to use your CAS calculator to double check. For example, shift class minus 1 to 1, 1 over bracket 1 plus x squared, whole thing squared dx. And if you try option B, just type it out like 0 to pi on 4. Two lots of cosine, let's just use t squared, t. That is true, so option B must be correct. Length of the curve. Okay, length of the curve, parametric form, and the formula is on VCAA formula sheet, and you can check it out. The way I'm gonna do this is I'll take the derivative of a matrix, treat these two equations as one vector function, say e to the power t times sine t, comma, e to the power t times cosine t, and you get something like that. Then you just take the norm of the velocity. So it's root 2 e to the power t. Therefore, if you want to calculate the length of the curve from 0 to half pi, you just integrate this bit. So I'm going to get option C, if I'm not mistaken. And it was calculating the arc length, all right? Next one, the area of this surface of revolution. This function from 0 to 1 rotated about the x-axis. So I have 2 pi 0 to 1 y square root 1 plus dy dx bracket square dx. And I'm going to get a 2 pi integral 0 to 1 1/3 x to the power 3 plus 1 plus something squared dx. The derivative dy dx is going to be 3 over 3 x squared. So that's just x squared. So I'll put an x squared here. And because we are having the privilege of a TIN square, I'm just going to go for 0 to 1, 2 pi times a fraction, x to the power 3 divided by 3. And then I multiply this by a square root. 1 plus x to the power 4. Make sure you square this function, okay? So we have pi over 9, 2 root 2 minus 1, option B. These multi-choice questions are super easy, very doable. Okay, a drone is rising vertically. Okay, let's say a bot is riding vertically. When it reaches the height of h meters above the ground, it is traveling at a speed of u. So this is a Suvat problem, I suppose. This is h meters. And here, this is u meters per second. At the height h meters, the drone stops working. So it subsequently falls to the ground. Suppose the air resistance is negligible. We only have, let's say, the acceleration equals to minus g, okay, or minus 9.8. You can see all the answers, all the options are in terms of g. Therefore, I just keep the g here. Now, the process is like this. Rising up a little bit until it reaches a zero velocity, then it drops back to the ground. So I'm going to use S equals to ut plus half at squared. in this case, if you set your initial position as your zero displacement, then let's say this is s equals to 0, s equals to minus h, because you can take the upwards as positive, okay? So you use the suvat, and you have minus h equals to, yep, this is still u times t, plus half times minus g, minus half g times t squared. And we want to find the time taken for the drone to fall to the ground. So you can use your CAS calculator, solve button, minus h equals to u times t, minus g over 2 times t squared, comma t. And you get two expressions. Now, to analyze these two solutions, usually we take the positive value. But here I would go just one step further. If I look at a similar graph like this, it's like a negative quadratic. This is identical to minus half g t squared plus ut plus h equals to 0. So I'm looking at this equation. For example, if I plot it like that, I know it's starting from, let's say, a height h, and it goes back to the ground, like reaching the 0, for example. So I must take, let's say, the positive t-value here. And I don't have any, let's say, any other values, okay? Any other values. Yep, that's pretty much what I'm thinking about. Just bring this back. Okay, so that is, let's say, you have t equals to u plus square root of u squared plus 2gh divided by g. For those of you taking physics, you might have derived a similar formula before when you're learning projectile motion, etc., etc. But I think the focus here is understanding the graphs and also the procedure, okay? So I'll say the answer should be option D. All right. Question 12, an object starts with an initial velocity of 4 meters per second at time t equals to 0. Okay, this is my initial condition. So I say t equals to 0, v equals to 4. You have a dv dx equals to 4 plus v squared divided by 2v squared. dv dx is not your acceleration, therefore I multiply v both sides. So this bit is now my a, and I'll get a 4 plus v squared divided by 2v. We would like to find a velocity at a time t equals to log e10. So I'm going to use an alternative of dv dt to replace the letter a. And then I'm solving this differential equation to get, for example, the t and the v relation. And then I'm solving this value for the velocity. Okay, so what I'm going to do is I'll go for dE solve. V dash equals to 4 plus v squared divided by 2v. And v naught equals to 4, comma t, comma v. So you get a relation like that. Then you're going to solve for v, given that t equals to natural log of 10. So you get a minus or plus 14. But the reason why we take a positive value is because your initial velocity is a positive value, and the acceleration, according to this function, can only be positive. And the velocity is increasing, okay? So it has to be larger than 4, etc., etc. So I'm taking only positive velocity values. All right. Consider two vectors A and B. A is minus 2i 3j mk. M is positive, and B is an arbitrary non-zero vector. The angle between them is pi on 3. So I can write A dot B equals to magnitude A, magnitude B times cosine pi on 3. And the scalar resolute of A in the direction of B is 4. So I say A dot B divided by magnitude B equals to, for example, 4. Just notice you can replace this bit here. So you actually get A, B magnitude cosine pi on 3. We can just write the half here divided by magnitude B equals to 4. Eventually, it turns out the B's canceled, and I should be able to get A magnitude equals to 8, something along this line. then you will get a square root of 4 plus 9 plus m squared equals to 8. So m squared plus 13 equals to 64, and m squared equals to 51. Okay, so option B is the correct answer for m value. Okay, so that is question 13. Question 14, consider the vectors A equals to I minus Pj and B equals to Pi minus 4j. A is parallel to B, so I'm saying, okay, the ratio between the I component equals to the ratio between the J component. And canceling the negative, you will be able to get 1 over P equals to P over 4. Cross multiplying P squared equals to 4. The magnitude of B, PE means magnitude, absolute value. It's true. Option B. If they ask you for the values of P, I would say P equals to plus or minus 2, but magnitude is 2 anyway. Okay, projectile motion. A cricket ball is hit from an origin hole at ground level. Okay, position is given by this thing. Displacements component are measured in meters. Fielder located as position 60i, so the location is 60,0. The distance in meters, the fielder must run to catch the descending ball at a height of 1.5 meter. The key word here, the prompt is descending, I would say, because if you draw a diagram, this is the trajectory of the ball, I would say, and when it's ascending, it's before this turning point, 1.5. But if it's a descending, you need to find a second time the ball will reach a height of 1.5. And then I'm going to say, okay, 19.6t minus 4.9t squared equals to 1.5. Then I'll get a t value, and then I can find a horizontal distance. T equals to something, then distance horizontally equals to 12 times t, and it gives you some value. But I also need to identify the location of the fielder, which is 60, 0. So probably it's somewhere here. What I'm going to do is I'll grab my CAS. Excuse me. Solve for 19.6t minus 4.9t squared equals to 1.5, comma t for t greater than 0, but you will get a second time, okay, as I explained. And the 12 times this value is 47. So it's not yet reaching the location of the fielder. The fielder must run to the left. That's why you get a 16 minus this value. You get a 12.93. So this is closest to 13, I would say 13. All right. Option C, right? Okay. Question 16, consider two vectors A and B such that A, B have, definitely if you get the magnitude greater than 0, it can't be 0. A dot B equals to 0 means the angle theta must be 90 degrees or half pi. So if you calculating the dot product between two cross vectors, cross product, one thing I would say is I'll write A cross B as it was, and B cross A as a minus A cross B with a dot in the middle. So you can bring out a negative, and you get A cross B dot A cross B. A dot product is like dot product between the same vector will be the magnitude of this vector squared. And this will be minus magnitude A, magnitude B, sine theta. If you take the magnitude of that, that is like, magnitude A times magnitude B times the angle, the sine of the angle in between. So eventually you get a minus A squared minus B magnitude squared and a sine squared half pi. This is a 1. So therefore your answer should be minus magnitude A squared times magnitude B squared. Option B is the correct answer. Okay, question 17. Two sides of triangle are spanned by the vectors 2, 1, minus 3, 1, minus 2, 1. Triangle area, so I take the norm, I'll take the cross product, 2, comma, 1, comma, minus 3, comma, 1, comma, minus 2, comma, 1. And this is giving me the area of the parallelogram, so I have to halve it, which gives me 5 root 3 over 2. There we go, option A. Question 18. For two non-parallel planes, pi 1 and pi 2, if two planes are not parallel with each other, they must be, let's say, intersecting. Something like that, okay? The cross product of their respective normal vector n1 and n2. Okay, so if this is, let's say, n1, and let's say this is like a n2, the cross product must be perpendicular to both. So roughly it's along this direction. So this is v equals to n1 cross n2. Okay, how does this look like? First option is will be parallel to both pi 1 and pi 2. Yes, that's true, because if you look at this line, this is a line in the direction of the cross product between n1 and n2, and it does not belong to this one or this one, so it has to be parallel. Option A. This is a terrific conceptual understanding question. Okay. Alternatively, if you look at them individually, say a line is perpendicular. This is a line perpendicular to a normal to the plane. So say this is the plane. Yep, it's parallel to, line is parallel to the plane if it's perpendicular to the normal of the plane. And the same idea, if you just look at this line and this plane, yep, parallel to both pi 1 and pi 2. Question 19. W is a random variable such that W equals to AX plus BY. A and X and Y are independent random variables and A, B are real numbers. Okay. Expected value X is 1. Expected value Y is 2. Expected value W is 1. Okay, so I have expected value W equals to A expected value X plus B expected value Y. So EW is 1 and EX is 1. So A times 1 plus 2B. Therefore, I can get A equals to 1 minus 2B, something along this line. And if you use the variance W is A squared variance of X plus B squared variance of Y. Variance W is 6, so 6 equals to A squared times variance X is 1 plus B squared times variance Y is 2. Okay, so I'm going to get 2B squared plus A squared is 1 minus 2B squared, take 6 equals to 0. See what I'm going to get for this one. 2B squared plus 1 minus 2B whole thing squared minus 6 equal to 0. You'll actually get a 6B squared minus 4B minus 5, so option D. Okay, certain electric components have resistances that can be assumed to be normally distributed with a mean of 1,000 ohms and a standard deviation of 20 ohms. Okay, sounds like a physics question, but it's a proper start question. So let's say X is a normal distribution, 1,000, 20 squared, that's a variance. Two independent random variables, random samples of 25. Okay, so X1 bar is the sample mean distribution of X, and the variance needs to be divided by 25. And the other random sample is X2 bar. It still has the same mean value. The variance is 20 squared over 25. And what is the probability corrected for decimal places that the two sample means differ by less than 5 ohms? This is a very common type question since 2019, I would say. You would need to find, let's say, difference variable, which is X1 bar minus X2 bar. So the expected value of D is 1,000 minus 1,000, which is 0. But the variance, you have to be careful. This is variance of x1 bar plus -1 squared, variance x2 bar, okay? So this is 1 squared times that plus -1 squared, variance x2 bar. So you actually get 20 squared over 25 plus 20 squared over 25, which gives you 800 divided by 25. And the standard deviation D is going to be root 800 divided by 5, something like that. And defer by less than 5 ohm could be either x1 minus x2 less than 5, or x2 bar minus x1 bar less than 5. So eventually I just need my D greater than -5, less than 5, okay? And that's what I'm going to calculate using norm CDF. So I go for norm CDF. And then I say, all right, -5 to 5, 0, square root of 800 divided by 5. So the answer is 0.6232, option C.